Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. I've recently added another workstation to my CNC mill, and as luck would have it, since I've only run 3 for quite a while, I don't have enough of these stops. So we're going to have to outfit the final vise with one of these Outrigger style stops. This is a nice little project. It is not all that hard to do, and I think we should just get started and show you how to do it. And based on the size of your vise, this is a 688 Kurt. There's 3 688s here and a 675 on the end. 675 is normally for my manual mill, but it's nice if you have a big table, use it, right? Let's cut the material up. I'll show you the dimensions, I'll show you the techniques, and you can get one of these on your machine. They are incredibly handy to have. Let's do it. In addition to the component that bolts directly to the back of the vise, and that is going to be driven by the type of vise that you have, you're going to need 2 other components. These little rods, some will be straight, you're going to bend some of them, you're going to end up with a bunch of these, but when at the end of the day, you're going to end up with a bunch of them. One of the things you want to try to do is make sure that whatever hardware you use, and it's in 3 different locations, make sure that the screw is the same size. Not necessarily the same length, but quarter 20, M6, whatever. That way, when you adjust your setup, you grab one wrench and you can change the angle, the length, the pitch, the extension, all in one shot. So it makes it a lot easier to do. Let's go over to the saw, cut some material, make this happen. Let's start the build with the 3/4 diameter 3/16 stainless. This doesn't have to be 3/16 stainless, but this is an off-the-shelf component, off of my shelf component, and I'm going to face it off and prep the end for a nice chamfer. And then we're going to drill and tap this thing into submission. We're going to put a quarter 20. That's a number 6 drill. I know the chart calls for number 7, but we're going to start with a number 6. I'm going to center drill this with a 5/16 diameter center drill. Now I could use a quarter inch for a quarter 20, that would be great. But with a 5/16, using a larger center drill allows you to put the chamfer on the thread lead with the center drill. You do not need a second tool. And if you're thinking large production, if you can cut a tool out of the loop, you've done good. .316 stainless will work harden, so if the chips are flowing, keep the cutting going. And believe me, you'll feel it, whether you're pulling on a quill handle or feeding a tailstock. When it's moving, keep it moving. I am using anchor lube to drill this stainless. It's a lubricant that I have found to be quite effective. Got it from Stan at Bar Z, and I believe All Industrial provided it. It's a great lubrication for drilling stainless. And if you're going to tap a hole and there's room below the required thread depth, drill the hole a whole lot deeper. That way you don't have to worry about the chips packing up in front of the drill, and you don't have to mess around with bottom taps and taking a half a thread at a time. Back side of the rod is just a simple faced off end chamfered. And since this is a sliding component, this will go in that split block. Make sure that the OD is free of burrs and relatively cylindrical. So shine the whole thing. This is really not a cosmetic, let's make it pretty kind of part. This is just so it's functional. Once again, the anchor lube with the tap. I'm using a Nerl spring-loaded tap guide. And the 316 is, it's a little bit fussy. It will work harden. So Sometimes it's good to push the tap, sometimes it's not. Whatever you do, don't use a dull tap on 316 or 304. You can get away with it on some softer stuff, but for stuff like this, go for a new one. I'm using a 2 flute. I should probably be using a 3 or a 4 flute, but the 2 is the sharpest one I had, so I compromised on the number of teeth. Setting up for the cross hole on the end, I'm going to use 5 parallels. Tall one in the back, 2 shorter ones in between, another tall one exactly the same size as the one in the back, and a top deck. That allows the round piece to lay in there and roll back and forth and not fall between parallels or fall off the top of where you want it to sit. You can trust it a lot better this way. There you go, piece of cake. Locating the hole is, you could do it 19 different ways. Edge finder, indicators, just to illustrate the many different techniques for picking up the edge of this part. I'm going to do it with a 250 diameter pin and a 2000 shim. As soon as the shim pinches, I know I have a 375 radius on the part, a 125 radius on the pin. All I need to do is move the y-axis in the total for a shift of 500. And that'll put me directly over the center of this rod. Finding the end is even easier. With the exact same pin in the drill chuck, line it up visually to where you're not going to drill through the part and hit your parallels. Instead of moving the table this time, we're going to move the part. Open up the vise and slide the part into the pin. Boom. Lock it down. Knowing the radius of the pin, move in 125 on the x-axis and give it a visual. Bring the pin down to the edge. If you like what you see, you're good to go. Make the offset to the hole center line dimension. Zero your dials, zero your digital. Lock everything down. Let's get ready to cut. For the cross hole, I'm going to use a full-size 250 center drill, not a spot drill. I'm a big fan of center drills. I believe it gives you an advantage when it comes to starting at full diameter. And I'm going to go until I see the full diameter of this center drill clean up on the diameter of the rod. If you only go partially, you're going to have an elliptical shaped lead, and the drill could bounce around depending on what size drill that you start with. Make sure that when you drill across a cross hole like we're going to do here, especially one with threads, the first third of this hole is going to be real easy to drill. And as soon as it gets to the center, it's going to want to grab because of the interruption or the opposed surfaces that you're drilling across. The spindle, the quill is going to want to bounce. So put some light drag on your handle. Keep it locked so that you have to overpower the lock. And that'll keep the drill from bouncing as it goes across the center and grabbing and accelerating when it breaks through the backside. I'm going to slow the reamer down considerably, put the machine in back gear. Running this is about, I guess it's about 180 RPM. And I love this anchor lube, but make sure you clean up afterwards with a rag. If you leave this on your machine overnight, it'll turn your steel black. So I found that out the hard way on the lathe. Good stuff, but don't use air on it and blow it everywhere when you're done. Put a rag underneath your part and make sure that you wipe everything down when you're completed. Continuous feed on the ring. There you go. Clean it thoroughly. Now let's take it over the bench. Take a look at what you got. Alright, when you're done, the finished product should look like this. Do everything you can to reduce the crown around the hole on the back side where it pushes out or the top where it starts. I put it back in the lathe and just lay a flat file on it and let it rotate until you feel the bumping going away. Tap the hole again, make sure that the reamed section of your bar did not roll the threads over, and make sure that the threads can go all the way through. I passed the reamer back through here by hand, and I re-tapped it, and I did them both twice. Then I hit it on the Scotch-Brite wheel, and away we go. Now, some people have asked me why I use a center drill as opposed to a spotting drill. With a center drill, naturally you can put a lathe center in it, but with a center drill you get more of a cylindrical footprint with your drill before you hit the entire face of the drill and have to start pressing against the web on the drill. So if that makes any sense, it's like having a pilot hole for the drill that you're going to use. So you get a little bit more penetration before you have to start applying the pressure. Screw that you choose, make sure that you put a cone shape or a dog point on the front of the screw, so that when the screw goes through into your bore and makes contact with the cross rod, it's going to mushroom, it's going to distort, and if you don't have some type of a cone point or a cylindrical point on it, you're not going to be able to back it out. Another good idea is the rod that you stick in there, put a flat on it. That way if there is any damage to the rod, it is on the flat and it's not on the OD, and it won't mess up your part on the way out. There you go. Simple and effective. Works very well. And you can crunch down on it, it's not going anywhere. Overall length is not important. I believe this one is about 8 inches long. And that is more than sufficient for about up to 12-inch wide parts. I have a variety of these rods. I'll show you them at the end of the video series. Now let's go over and make the part that connects to the vise. Four-jaw time. For the remaining two pieces in this build, you're going to need a four-jaw chuck. And when I change my chucks out, I have a wooden cradle that I sit underneath it. It allows me to just gently tap the chuck loose and slide it out like a drawer. It works really well. My four-jaw chuck is a little bit smaller than my three-jaw, but it gets me close enough that I don't have to stand here straining while I line it up and lock it down. When I do tighten the cams on my chuck, I go around twice to make sure everything is seated. And it's good to go. Make sure all the jaws are in the same orientation. Let's do it. Now, a trick that I use for smaller stuff like this, I know I'm going to use a 1-inch square material in the end, so I'm going to put a 1-inch round bar in here, and I'm going to indicate that to run true. Depending on what the faces of each of the jaws in your four-jaw look like, this is going to get you very close to running true. I do have a video on the clever way to indicate a four-jaw chuck. I will put a link to that video in the video description below. And a couple of passes with the chuck, about a minute later, and we're running true. I'm going to clean up the face of each jaw, and I'm going to mark 2 jaws in the chuck that I'm going to keep in the exact same position through the entire process. They are not going to move. I am going to work this material with 2 jaws now and use the red jaws as stops. The body of my chuck is marked with an OK around the key position, so that I don't accidentally lose my location on those 2 jaws. And you can see visually it is spinning very close to spot on. If this were critical, naturally shim it up, indicate it, do what you got to do. It's going to be hanging out about 4 inches, so I am going to put a center in the end and support it so that we don't get any taper, push off, chatter, or anything else that could ruin the actual component we want to form. Once again, working with only the 2 jaws, going to spin it up and away we go. You're going to see a couple of choppy frames here. That is just because this is not something you need to sit and get old watching. These parts can get very hot, deceivingly so. And here we go, watch this. Water's going to steam right off of that as it hits it. It's not a good idea to check a part that's that hot. You want to make sure you blast it with some air, cool it down, drape a rag over it with the machine turned off. Get it down to room temperature or cool take your final cuts. And before you take a final measurement, make sure you hit it with some Scotch-Brite or something just to take off any uglies that may be clinging to it and you're not checking it over burrs. Got to put some very healthy chamfers on this part to take the sharp edges off. And for cosmetics, because when that end is almost a round face that transitions into the square, I just think it looks better. So we're going to break the corners off until it's almost a 1-inch diameter formed on the face, and the same thing on the nose. Okay, let's go over to the bench. The jaws on all of my vices are about 6 inches wide, and so is the mating component right here. What I'm going to do is I'm just going to mark the 3-inch point, the center line, and I'm going to work the entire part from that center line. Half in each direction. When you set this part up to drill the cross holes, make sure that the parallels are thin enough so the drill doesn't hit them when it goes through. I'm going to X-axis align by eye to the mark I put on. And the Y-axis, I'm going to walk this 250 pin off the edge. I know I'm 125 from the edge now. So I add that to the 1/2 inch, and we are on center X and Y. The 675 and the 688 Kurt Vise is 1'937" off center each way. So with my digital zeroed, I'm going to move 1'937" off to the left and push this drill through. Peck at it initially or you're going to get one of those trapezoidal looking holes at it, and it's just not going to cooperate. Once you got a nice chip going, keep the coolant in there. Peck it so that the curls don't get too long. And beware, this is going to generate some heat as well. You can see the smoke coming out of the hole. I've seen a lot of people grab a hold of drill bits after the machine has stopped to change to the next size, not realizing that the drill is going to burn you. So be real careful if you do this. If you haven't done it before, it's not something that you're going to get burned by twice. Figuratively speaking, of course. You will get burned once, but not twice. And to make it look good, we're going to chamfer these holes. Slow it down for the chamfer operation. There's no need to burn up high speed on stainless. And just out of camera range, I am physically pushing this stop up against that to deburr the other side. This part is basically done. Okay, let's take a good look at the final component in this assembly. And what I'm about to tell you is the way that this one is built, the way that I chose to build this one, and not necessarily the standard, if there is such a thing. So let me point out some of the details of this that make this easier to make than it may appear. It doesn't have to be intimidating. When you space a hole on the end of a split block like this, a couple things that I would like to stick to as a rule of thumb for myself. I like to know that there is a web on the block itself that's thinner than the screw. Okay, that way I know that when I draw down on this screw, this is going to flex. If this is a lot thicker, then the mass on both sides may give you a little bit more resistance than you want. And if you have a small, shallow thread, chances are over time it's going to pull the thread out or ruin the screw. That's point number one. The distance from the end to the center of the feature. How much do you leave right here? Well, it depends on what screw you're going to use. You can see that I've left the size of the head. That assures that when you run the screw down, the screw is going to be flush with the end of the block, and when the screw passes through, you're going to have sufficient threads on either side of that screw to engage the other side. Simple, right? It really is. This split right here does not have to be critical. It does not have to be right on the transition of the through hole to the threaded hole. So if you've heard that before, that's not true. You can drill your through hole, sooner or later, there it is. You can drill the through hole deeper if you wanted to. and now your threads are down here. So as long as that's split, I'm actually looking through the camera and not at the part. So long as that split right there doesn't fall in the thread, you're fine. If you want to take the through hole component and not hit directly on center, if you want to go 1/16 of an inch, millimeter, 2 millimeters below center line, and then when you split it, you can split it with a saw. This condition here will not hurt you at all. So this is not a critical slot. Okay, not critical at all. Drill this hole a little bit deeper. Boom, you can put that anywhere you want, just don't put it through the threads. Now the beauty of this block is it's exactly the same. From this side to boom, presto changeo, look at that, Sharpie marker's gone. To this side, exactly the same. So the only other dimension you need to worry about when making something like this is this distance right here. Right there. Okay. Now, when these things are theoretically passing through each other, you would like to maintain some type of wall right there. It can be thin, because when this thing is all clamped down, the block thinks it's solid and it's going to be very rigid. So in order to figure this out, we're going to take the diameter of the head, we're going to take the diameter of the rod, and the gap. Let's say the diameter of the head, the diameter of the rod, times 2, plus the gap, and that will give you the overall length of the block. Now when I'm going to do this in the machine, I'm not going to take and drill this and then come over and drill this and then just keep messing around. I'm going to drill one hole, I'm going to flip the block, bank off the end, drill the other hole, rotate it, drill it, flip the block, drill it. So the machine is not going to move as much as the part is. The only thing that could vary in a situation like this will be the web, because the features will be exactly the same from end to end. And the only thing that would be critical or not would be the length of the prep block. If the length of the say that 3 times fast. If the length of the prepped block is shorter, it will affect the web if all of these features out here are located accordingly. Now I'm not sure if I'm going to do this in a boring head or in a 4-jaw. I might do it in a 4-jaw just for fun. But let's do the final piece, get it done. And as a time check for exactly what's going on, it is, let's see if we can, there you go. Man, I'll tell you, focus on this camera, I'm just, like the camera, disappointed with the control over the focus. Big time. My giant indicator clock says it is 10 a.m. Yeah, it's even 10 a.m. from this side. Yes, it moves. Alright, let's begin. I am fortunate enough to have the machine still on center from drilling the main bar, so this dimension is already set. I like the piece where it is. This is a 250 diameter pin. I'm just going to bump it right up against the end since this is not a precision part whatsoever. Zero out my X. Moving it in half the diameter of the pin puts me right on the edge. Let's go 0. Now it's a good idea to put the stops on first, but I know I have an extra wet material in here, so I'm going to push the stop against the jaw and against the part. Snug it up. For the sake of repeatability, now bump the part. Okay, let's do the big holes first. I'm using the same drill that I drilled the cross holes in the main bar with as my pilot holes. Just as a good rule of thumb, if you have a bunch of parts that are symmetrical, they look almost the same, I like to mark the corner that's going against the stop. Doesn't take long, just a little bit of Sharpie marker and you're off. Silver and Deming 11/16 drill, 1/2 inch shank. Love these drills. A little bit bigger hole. Little safety tip here for you guys. When you are drilling a hole that has a pilot hole, chances are you're going to get these long stringy chips that are going to helicopter off of your part. All you need to do is burp the drill like that. Just stop feeding for a second and just give it a little bump in the opposite direction. The chip may still cling to the drill, but the chip that forms from the next cut will eject it. You do not want a long swinger on that drill. Very dangerous. And for those of you that are going to question why this is important, if your y-axis alignment is off, you can see that it will stay off to the exact same side if you put it back in the same. If you put it in reversed, the hole will jump to the side of the error. That philosophy of taking the drill and burping it on a CNC machine on a drill cycle, that's called a peck. And if you want to set your peck cycle so that the drill you're using on a CNC doesn't do that, use the peck cycle. Works very well. All right, let's shift off and move for the locking features. And with stainless steel, it's always a good idea on the tap drill to go one size larger than they recommend, depending on which stainless, of course. This is 303. This cuts like butter. It does not work harden. 304 will, 316, 316L, 304L, those are nightmare stainlesses, and they will harden if you dwell. So if you're cutting a 316 or a 304, make sure you keep the tool moving so you don't harden the surface. 303 you don't have to worry about. It's a very nice material. Tap drill is usually a number 7, which is a 201. I'm going to use a number 6. Same drill that I used for the rod. So keep the tools handy. If you're making one of these, keep everything in a cup. You will use them again. Don't forget to rotate the part because you are working against a split line now. Once again, mark the part. By using a larger center drill than the hole that you are going to finish with, if you go a little bit deeper and form a diameter that's bigger than the hole, you can also deburr the hole at the same time you center drill. I'm going to set the depth of this feature by using the 250 gauge pin from the initial bump setup. tap drill first, all the way through. Alright, can you see the hanger? Watch this. Alright, there you go. You know how you do your weed whacker on your lawn, right? Well, that's stainless steel. You can imagine you get your knuckles in the way of that. It's not going to cut your finger off, but if it wraps around and continues to pull, it might do some damage. When you see that shadow showing up on the drill, get out. I'm going to go with a 257 drill here. I am going to look across this drill at the high spots or the main body diameter of this drill as I put it down into that center drilled section of the part. I'm going to look at the shadow on the machine behind it to line up the edges of the flute with the top of the hole. Alright, I like it. Set your stop on your quill right now. There you go. Stop. Bring the table up. Half the distance of the block, plus the slot, plus whatever else you want to go. I'm going to go, let's say 500 to center, 530. I'm going to go 590. And that should serve me well. Let's make it an even 600. 1, 2, 3, 4, 5, 6. That'll leave me with 400 worth of thread, which is more than sufficient for a 1/4 20 screw. Time check, 10:30. Okay, for sake of consistency, I am going to leave the block positioned as is and tap the hole from this side. Yes, you can flip the block over and tap it from the other side, but if you have any Y-axis misalignment on the center line of the part, when you flip it, you may drive the tap in sideways if you don't relocate that hole. Same tap as the rod. Okay, just for fun, let's do this in the 4-jaw. Let's make this 750, and then we'll saw it apart, see what we got. For a quick rough alignment of the part, I'm going to put some spacer blocks behind the part. I'm going to stick the part in the 4-jaw chuck, and I'm going to bring a live center in, applying pressure to the hole, and keeping the shims against the face of the 4-jaw chuck. I will lightly bring the jaws down to make contact with the part. And this should get me right within the range of the indicator. When the time comes, I can take the spacers out, put a pin in, and indicate the pin to get the part to run true. All right, now I'm sure everybody has a different philosophy with how they use their 4-jaw chuck. And I am, I only use it for square stock. I'll admit that. I don't use it on round stock ever, unless it's an eccentric requirement. But what I'm going to do is I will leave 2 of the jaws just lightly snugged so it supports the part, and I will work with the other 2 to push it to where I need it. And then if need be, I will make sure that they're lightly snugged, and I'll use the opposing 2 jaws to push it where I need it. So you always want to hold on to the part and not let the part drop out. I've seen way too many guys leave the jaws open, and when they make an adjustment one way or the other, the part falls out. So let's see if that works. All right. So let's do snug, snug, work with these guys. I will unloosen this one so I can push the part in that direction. And it's close enough that I can start working with both of them. That's a good sign. Close enough, it's only a stop. One of the things that you need to be very careful of is this has a thin wall on 2 of these jaws, and the jaws are directly in line with the hole. If possible, be very aware of the wall thickness of the part that you're clamping on, and do not squeeze and distort the hole. It will be round while you're boring it, but it's not going to recover when you let the pressure off. It's going to distort. Let's set up the boring bar, knock them holes out. I am using my favorite boring bar to do this. I got this from the Solid Rock Machine Shop, so look them up online if you like what you see here. I beat the living daylights out of this bar, and it had just performed very well for me. Look them up, Solid Rock Machine Shop. Love this bar. All right, let's talk about this setup for a second. If this was a precision part and you're setting it up in a 4-jaw chuck, not only is the concentricity of the feature you're picking up on important, but the face is important as well to assure that the hole is not whipping and you are locating your indicator on the 0 point between the 2 eccentrics. So if this was a precision part, you would very much need to indicate the face of this part, but since it's a stop, we're not going to worry about that. Secondly, you saw me bore about the first 100,000ths of this part just to get the first plug gauge to go in, which was 2/1000 of an inch undersize. I made my adjustment to the 750. The 750 starts very nice in the front, goes about 100,000ths of an inch deep and stops. That is because of the change in tool pressure and minimal deflection to the tool at that point. I have returned the tool to the 180 setting on my dial. I'm going to hit it again. It will probably cut lightly at the very beginning and a little bit more at the 100,000th depth. Let's see if that's so. Minimal witness in the front. Definitely more chips at about 1/8 of an inch deep. I suspect the 750 pin is going to go in there just beautifully, which it does. All right, one other thing to consider when you're doing off-center work like this, you have a considerable amount of mass because of this side and this jaw being off-center and asymmetric to the rest of the setup. If you were to run this at an extremely high speed and the machine has any type of wear in the head, stock bearings, spindle bearings, this will run in an elliptical trajectory. The hole will come out egg-shaped. So when you have a setup that's out of balance like this, if you can get the machine into a neutral where it likes to float, watch for the low spot. If the machine returns to a low spot, counterbalance it if you can. This is very important with faceplate work and large setups, angle plates, bigger components, etc. Okay, so be aware of the offset. I slowed the RPM down a couple of hundred RPMs because I could literally feel this machine shaking from this particular outrigger mass. So by slowing it down, you can reduce or negate the elongation of the feature. That's the little one. That's money. Do not leave the plug gauge in the part when you open the chuck. That plug gauge might become part of that chuck. Now, like I did before, I have 2 jaws marked here as OK. Those will be the ones that I open up when I flip this part. But first, I'm going to deburr it. This is the OK jaw, and this is. The red ones stay put. They are the vice stop, so to speak. And for proof of concept, I am not indicating this part. We're just going to go for it. Okay, let's split it. Okay, in keeping with my philosophy of at least 2 teeth in the part, this wide, aggressive aluminum wood type blade, you can see how aggressive it is. I think it's 4 teeth per inch. Should do fine on this stainless. Slow the RPM down, use coolant, and we're going to know real quick whether or not it's going to work. If you saw me lay the mark out on the end to cut, if you lay a mark out and it's not exactly where you want it, we'll make one that's wide enough so that where you want it is in the middle of the wide footprint. It's exactly what I did. So I'm going to center this blade up by eye on that mark, and this is proof positive that the split is not critical. Let's see what happens. It's a very good idea after any operation that could produce a burr that throws the part off, remove the burr. Run a file across the part. And there you have it. I'm going to clean those burrs off. I will take a round file and go inside this bore to get the crown that showed up after the bandsaw slice. You can use a round file, the edge of a square file, triangular file, anything that will get down in that split and remove that burr. You can see that burr because that will interfere with the rod. I'll do that to both sides. I'm going to knock the corners off on a Scotch-Brite wheel because those are knuckle busters. And let's put it together and see how it works. Time on the clock, 11:19, and I stopped for a cup of coffee, so not bad. I think you can see that the opportunity for multiple configurations of this particular setup are abundant. This block does not have to be positioned on the bottom. It can be positioned on the top. You can come over the top and get down inside of your part should you need to. The offset rod will allow you to get very close to the top of your vise and not get in the way with the stop. You can see that it's almost invisible. If the screw were shorter, it would be invisible. Trust me on that one. The other good thing about this is if you have a long piece that hangs out of your vise, you can take the stop rod out and use this as a diving board support if you need to do work out here, drilling holes, whatever. You are only limited by the length of the part that you make back here and the reach here. Everything else is up to you. That is a really nice thing to have. I have 4 of these now. This one is all 303 stainless, and I will put the numbers down to let you know exactly what you're looking at in case you care to make one. Fun project. Thanks for watching. Have a great weekend.